Okay, Year 9. Today we're going to have a little look at concentration and how it affects rates. There will be a couple of videos today. This first one just to introduce you to the ideas like we would normally at the beginning of the lesson, and then another video showing you the practical and the results from the practical, so that next lesson you can do the analysis and the extension work on the practical with some results that I will get while we're here. So, concentration. Concentration, guys, is defined as the measure of how many particles there are in a fixed volume. And in chemistry, that is usually 1 decimeter or 1,000 centimeters cubed. If you think back to our surface area lesson, that's the 10 by 10 by 10 cube we were talking about would be 1 decimeter. As you can see from our little diagrams, if something is at a high concentration, you would have lots of chemical particles within the volume. A low concentration, less chemical particles within the volume. So, 3 questions for you to have a little think about. Try and answer them, so give the video a pause, see if you can answer them, and then come back to me once you've got an end to the sentences. Okay. So if we add more of the chemical particles to our solution, we would be putting more circles, more particles in the same volume. So concentration would go up. If we add more water to our solution, we would be increasing the volume. We'd be making these boxes bigger, but we wouldn't be changing the number of particles in there. So concentration would go down with dilution. If we add more of the same solution, so I take this high concentration solution and just pour more volume of it in, the concentration will stay the same because we're adding the same amount of particles to volume. It's the same ratio still, so the concentration would stay the same. Okay, so now we need to think about how our concentration then affects our rate. So again, give the video a little pause and try and end those 2 sentences for me. So hopefully you have worked out, as concentration increases, our rate of reaction will increase and our time to react will decrease. And like before, if I decreased my concentration of my reactants, I would swap these 2 around again. Same idea. Okay, so this is because, again, we're going to relate back to our 3 things we need for a reaction. We need a collision, we need orientation, and we need the activation energy. So, similar to the surface area, guys, we are only changing one of these 3 things. Remember, temperature has the biggest impact because we're changing collision and activation energy. So our first statement, as always in the test, is to say what has changed about the particles. So as concentration increases, what has happened to the number of particles? We have more particles in the same volume. Okay, so remember we've added more particles into the same volume of things, so there are just physically more there. And you'll be unsurprised to hear that this leads to more collisions per second. And remember that per second, very important, guys. If we don't say that, we don't get any marks. Same idea as all the others again, guys. If we were doing decreases, we would just swap our words more for less to get the same idea at the end. Okay, hopefully now, guys, you can go ahead to the next video and we can have a look at the practical you will be doing.